So, welcome again. This is the laboratory of the Base Innovation Center. So, Base Baha'i has a research center and training center called the Base Innovation Center. So, the Base Innovation Center is divided in 3 stations. We are in the first station, this is the laboratory. So, this room, we have our universal testing machine. Carlo Catalando is our research engineer. He was an intern here coming from De La Salle University, and he became our research engineer here in Base. So we conduct a lot of researches in this laboratory. Some of them, for example, is testing the chemicals that you need to protect the bamboo against an eye or a bug. Okay? So in this box, you can see the bamboos that are untreated in the right side. And you see all the ores, the powder, even the dead bog there. And then on the left side, we have the treated ores. So you see bog because they can crush. There is holes in the back and they can crush. But you don't see powder on the side. And you don't see holes in the bamboo. So that's how we check the solutions and the concentrations to be sure that the bamboos are properly treated. So one of the issues with bamboo in traditional constructions like Baha'i cubos or nipa huts is that the bamboo is not durable because it's not treated. But it's not a problem of the material itself, it's a problem of the technology that people has not access to the technology. Once you have access, you can produce a very durable material. And for how long the bamboo will be protected using these solutions? Forever. So it's not like you get 5 years and after 5 years, God will leave. No, it's forever protected. So it's how you can use the materials. Now, here in the laboratory, so we're going to conduct a test. It's a bending test. So this bamboo will be pushed vertically, and we're going to make a bending failure. And Carlo is already started that. So this is a typical bamboo, the most common species in the Philippines. It's called Bambusa blumeana. That's the scientific name, but it's well known as Hawaiian tinic. So Hawaiian tinic is the most common species in the Philippines. It's a species originally from the south of China that, we don't know how, hundreds of thousands of years ago arrived to the Philippines, and it found like its paradise and it spread everywhere, and it's the most common species that you can find in the country right now. So one of the reasons we are working with bamboo is because humans have been living in bamboo houses for thousands of years. People in the Philippines have been living in Baha'i cubos before the Spanish arrived. That's same situation happened in Africa, in Latin America, everywhere. However, bamboo engineering is something that is relatively new. Only 30 years ago, we started to research about the properties of knowing how strong is this material. And what we are doing here in the Innovation Center is working with 7 local universities. Some of them are UP, De La Salle University, UP, Mapua, I forget the rest. And these universities coordinate with us the research topics, and they send us the students, and we provide them not only the equipment, also the materials and the supervision so they can test the materials. Let me tell you something. There is around 1,600 species of bamboo in the planet. Around 100 could be used for construction. You know how many of those 100 we already know the properties? Only 4. The species from Colombia, the species from the Philippines, and 2 species that we call global species. Giant bamboo, because you can find it everywhere in the world, and Bambusa vulgaris, because you can find it everywhere in the world. Only 4 of 100 that we still need to research a lot. However, for the Philippines, that is what concerns us, we already know the properties of the species, that the main species in the country. So why is it important to work with bamboo? But before that, this is going to very soon. So you can be close, not that close because somebody lose an eye as well. So what is the load now? 400 kilos. 400 kilos. I think it's resisting already 400 kilos. It has already the first failure here. See the crack? It's getting low?
It's getting high.
Okay. I forget to ask you what is your guess on the low, but we are expecting maybe 500, 600.
About 600.
Yeah. But already the crack is started here, so we can see the failure going to happen soon. So this is what we make here. So we test many bamboos from all of the regions in the country, and then we determine the values to design structures in a safety way. So why is important the use of bamboo? Why we decide, Base Baha'i and Hilti Foundation decide to use bamboo? And the main reason is it was
Ibig sabihin, malalaman mo kung pwede
what was the low?
tapakan ng
500.
Half a ton. So we resist half a ton here. This is bending, no? Now if we get a bamboo like this one, for example, we get a sample like this and we tested crushing it like that, it will resist 10 or 15 tons. You know, that's like putting 15 bios one on top of the other. Okay? So that's how strong is this material. So when people used to think the bamboo is a weak material, and it's nothing more far to reality than that. It's a strong material, and the durability could be addressed with the proper treatment. So those are the things that we need to address. But it has this misconception of being the poor man's timber because it grows so fast and it's so abundant that the poor people can access very easily, but without treatment and without knowing which are the right poles, they harvest the wrong poles, and then the bamboos get rotten very soon and people, oh no, this is a bad material. But it will happen the same if you take some pieces of steel and you make a shelter and the steel start to be corroded by the salt. So that's the same situation. Anyway, I was telling you the reason Hilti Foundation and Best Baha'i decide to work with this material is because bamboo is one of the best materials to capture carbon from the atmosphere. So when you build houses like the houses I am going to show you in a while, this system is around 60 to 80% lower in carbon emissions than conventional concrete hollow blocks that we use in the Philippines. So every time we build a house, it's 60% lower in carbon emissions. That's how many tons of carbon, Maricel? Like 12 tons of carbon? Yeah, per house that we are not sending to the atmosphere. And there is an additional advantages. All the bamboos are storage in carbon, and that carbon will be inside the house, like trapped inside the house, for the lifespan of the house. And many of you probably are asking, what is the lifespan of this construction?
Yeah.
And the lifespan is equal to conventional construction. Because if you protect the walls, and I will show you how, from the humidity of the terrain, from the humidity of the environment and the sun radiation, this house can last 30, 40, 50, 60 years as any conventional house with no problem. Our oldest house in the country already has 12 years old in Iloilo and it's still pretty fine, no problem, no maintenance, nothing. It's already a decade and there is no any issue with those houses. Some typhoons happen in the area and nothing to report. So what is happening in the world right now is that organizations like the World Bank and other organizations like give money to the countries to build social housing are starting to put some conditions in those fundings. Like your housing programs should be sustainable. This is the question. So should be sustainable. So maybe in 5 years or less, due to climate change, the funding that the country receive for new constructions should be conditioned to have sustainable houses, including materials like bamboo or timber. And the reason is because right now, 25% of the carbon emissions per year and this panel came from the construction industry. Nobody is talking about that. You see the issues in transportation, emissions in other kind of industry, but nobody is talking about the contamination of the construction industry. So concrete, steel, and aluminum only are responsible for 25% of the carbon emissions every year. And there's only two materials that can help us to reduce that. One is bamboo and the other one is timber. And in the tropics we have a lot of bamboo. We have timber, but our timber is in the forest, we cannot touch. In the north, they have agricultural forest plantations, like industrial plantations for wood, like in the US and Europe and Russia and all these countries, but we don't have that in the tropics. So we need to protect our forest, natural forest, and the way to use sustainable materials is using bamboo that is just a grass. A grass, in our case, the Kawaii pinic is a grass that grows 10 to 15 centimeters per day. So literally you can see it growing. So fast, the renewable is so fast. So now I invite you to the second station. This is our second station. Welcome to our reaction frame. So maybe you are asking what is all of this. This is a gadget that allows us to do full-scale test, meaning we can test components of the house like walls, trusses, big beams, columns, things like that. So what are you seeing here? This apparatus that you see here is called a dynamic actuator. And a dynamic actuator is like the jack of a car, but controlled by computer, that can simulate like an airplane, for example. This is the only equipment of those characteristics in the whole country. Not even the best universities in the country has that equipment. That's why they are sending us students, because they want to use these resources. So what you see here is a wall made with our technology. So you can look behind and you will see the bamboo frame. So please go on the other side and look behind. So you can see the bamboo frame in the back. And this is the plaster in the exterior side of the wall. That is the part that goes out of the house and protect the wall. So actually we tested yesterday, because this is part of a master thesis from Mapua University. So the test, the walls is already broken, but you can see more or less what is the dynamics. So please, can you move it with this one? Walls? I don't want to try to this one. So we tested yesterday, you still can see what are we doing here. So you see the jack of the dynamic actuator moving, and certain specific frequency, and you see the panel. So we tested and we have a load of 3 tons yesterday, pushing this like an airplane. And then what we are doing is trying to optimize the system. So we test different configurations, different ratios for the cluster. All the things you listen there is the panel being broken. So actually, here in the Base Innovation Center, we also have partnership with 7 international universities. Aside of the 7 local universities, we have partnership with University of Pittsburgh in the US, University of Coventry in the UK, ETH from Switzerland, Virginia Tech from the US, University of Science and Technology of Hong Kong, Universidad del Valle de Colombia, and I forget another one. But those are our international partners. So next month, a student from Switzerland will travel to Philippines for 2 months to test walls and these apparatus. And they have better equipment than us in Switzerland for sure, but they don't have bamboo. We have bamboo. Before, why we are working with these international universities? Because in the US, in Europe, they already know how important bamboo will be for sustainable construction in few years. So they are investing a lot of money researching about bamboo in those countries, but they don't have bamboo. That's the tricky part. So they are importing bamboo. So imagine how much is a container from the Philippines to the UK to test and to destroy, like we destroy in the laboratory. So it's very expensive. So for them it's cheap to buy a ticket and send a student here. But for us it's very important also because we access all the knowledge they have in that university. We can work with the professors there, and the international students work with local students here and with our team. So there is a real technology transfer from Europe and US to the Philippines. And the most important, the knowledge stay here where we need it. So that's what we are doing with the Innovation Center. And right now, Philippines and Manila and this laboratory is becoming like the hub for bamboo construction research. So 2 weeks ago, we have our Bamboost. It's a conference where we invite international speakers. We have one from Switzerland, one from the US, and one from Hong Kong, and another one from China. The representative of China was the director of housing for the International Bamboo Organization. It's an organization based in Beijing, and now we are starting working with them in a more international approach for how to, from the Philippines, teach others to use the technology. So now let me explain you. Sorry for this. This is some walls that we are prefabricating for a project in Bagusilagan. It's a Talipapa market that we are doing for some people that was relocated from Payata slum site, and we built 52 houses for them, like in 2015, Maricel? That's 2016. And later on, together with Ayala Foundation and Base Baha'i and Guilty, we do a food security program, teaching them to plant organic farming, and then a piece of land that they have there. And now they have excess of vegetables and things, so they have a small piece of land where we're going to make a small talipapa, and they can sell the excess of food production for their neighbors. So it's a livelihood program and many things. So these panels will be traveling to Bagusilagan soon, and we will clear the area. So you can see everything is prefabricated. All these panels are prefabricated and will be transported in a truck, and the talipapa will be assembled maybe in 3 to 4 weeks, and that's it. So here you can see we have two systems. One is this one that you see here. It's a frame made of bamboo. Be careful because it could be sharp, this mesh. This is a mesh called Rip Lat, and it's the only product that we import from China. It's a special design for plastering. It has a better fire protection when it's plastered than this system that is more traditional. And this is bamboo as well. It's called tat or sasa also. Yeah, in Cebuano is sasa, and Ilonggo is tat.
Tagalog is also tantan.
And Tagalog is also tat. And in Spanish is called esterilla, and English flattened bamboo. So this is the most traditional one, using tat plus chicken wire, and also plastered with cement in the exterior. So what of the two systems are better? Both are good, and both has advantages and disadvantages. So if you need to do a firewall, you have to use this one because it has 2 hours rating. So when we make houses, duplex with a firewall in the middle, that wall should be plastered in all the places so bamboo cannot be exposed. And with that protection, the wall can resist up to 2 hours of fire rating. If you use this system for firewalls, it only lasts for 1 hour. So we never use it for firewalls, always this. This one, on the other hand, has another advantages. First, create more jobs in the Philippines, no jobs in China, like this one. Second, the house is greener, meaning there is more carbon stored in the house. Third, there is a better thermal comfort inside the house because the bamboo plays a role like an insulation. So there's many advantages for both. Let's go inside the house. We'll start with the rest of the story. Welcome to my house. Mi casa es tu casa. Bienvenidos. My house is your house,
Yes.
as you say in Spanish.
Which is cheaper.
Yeah, I will talk about. The price is almost the same, so there's not a huge difference. Actually, that's a little bit higher by 3-4%, but that could be easily handled if we can produce in a big scale. Okay, so now this is our model, typical model house. This is 30 square meters house. Of course, we want to show different stages in the process of construction. So in that room, you see the house totally finished. And here outside you can see some of the components of the house. So let's start from the foundation. So normally this part is underground and it's the footing beam, concrete, reinforced, equal to CHV, however smaller in size because the house is twice lighter than CHV. So you don't need a huge beam in the bottom, you can do it small, and then you start to save money and also carbon that you are sending to the atmosphere. Then we have this CHV wall or zócalo. I know that's a word in Tagalog also. It's a Spanish word, but also in Tagalog. And I think it's a Latin word because it's also in German. I learned that from German visitors. So we have the zócalo that goes up to 30-40 centimeters above the ground level. The ground level. And what I'm looking with this zócalo is to put far away from the ground, the humidity of the terrain, my bamboos, to avoid the humidity to reach them. And normally we have a coating or a barrier, a waterproof barrier that stop the water, the humidity, because in a very, very rainy season, the water can go up by capillarity and try to reach the bamboo. So we need to stop that humidity to touch the bamboo. So you can notice now that humidity is the big issue. So we need to be sure the house is well designed and properly built to keep avoid water from the house. So now the walls are prefabricated and we prefabricate them in the treatment facility where the bamboo is produced. So BASE right now has a network of 6 treatment facilities, one in Batangas, one in Negros Occidental, another one in Negros Oriental, Bukidnon, Cotabato, and Davao. And these facilities can produce up to 12,000 pieces of bamboo per month. So with that, we can do easily 100 houses per month. So there's already a capacity to produce in a good scale. Could the country produce more? Of course, a lot more. Philippines is full of bamboos, and if you think in the north still we don't have anything, there's many regions where there's a lot of bamboo that can be used for construction. Okay, so you can see a prefabricated wall in the back, or those ones there, and this is the kind of wall that we install in the construction. So once you have the foundation, the prefabrication of all the panels for a house like this take only 3 to 5 days, and the installation with roof and the installation and connection of all the panels take maybe 1 week. And the rest of the time is just the plastering and the finishes of the house. So to complete a house like this is only 3 weeks to do it. So let's go inside
This
the room.
is how many square meters?
30 square meters plus an extension kitchen outside that is maybe 2 meters more. In the provinces, the families actually like more to have the kitchen outside. They call it the dirty kitchen, no? And then it's outside of the. At the beginning, we start to allocate the kitchen inside, but they don't like. They like it because sometimes they use fire, charcoal, and then they don't want the smoke inside the house, so they use it outside. So, what are you looking here? This is the normal level of the ground. It's a concrete slab. You can put tiles like in a house, conventional. And when you use the riblap mesh, the Chinese mesh, this is the kind of finishing that you have. Trying to. I mean, this is a starting. This is not like a brick house that you can move. No, this is really starting. And if you use the flattened bamboo, the tap, this is the kind of finishing that you will have. If you don't want to see this, but you still want to use that, you can plaster the inside also. But that's more money. It's costly. Bamboos are exposed in the interior, yes, because you can save money. However, if you want to put a mesh or a tap here and plaster, you can cover, and at the end your house looks like a concrete house totally. But in reality, it's about the bamboos because all the frames are inside. We don't do that because that's adding cost that is not necessary, and the house will be more expensive. Okay, so you can have ceiling. I actually prefer don't have it because it will be more fresh, more air circulation, so you can have that. And the cost of a house like this is around 280 to 300,000 Filipinos.
The entire finished.
Finished, but without tiles. I mean, finish the house with electric installations, plumbing, without ceiling.
It's installation is included or
Yeah. So labor and material finished with the toilet, with everything, with the kitchen. What is not included is the tiles, the ceiling, the internal paint, but the external is included. All windows are included, doors are included, and concrete slab is included, electrical and drainage system, septic tank. So, of course, the price varies depending on the location of the project. If it's a project near a treatment facility, it's cheap because the transportation of materials is cheap. If it's in a remote island where you need to bring all the materials, of course it's more expensive, but it will be more expensive for any material, even if you do it over there. So we have projects that are a little more expensive like that because the location. But in general, our projects in Negros with Habitat, I am talking about direct cost, materials and labor, not including profit of the contractor, overhead, and other costs that could be added to the construction. But talking about direct cost, material, and labor, we are 20 to 30% lower than conventional construction built using the building code. Our houses are designed to stand the same loads for conventional individuals. However, in the provinces, sometimes the regulations are quite flexible and they allow to build substandard construction. But even with substandard construction, they are the same price. And the difference there is that the substandard CHB houses cannot resist the earthquakes and the typhoons of the region. While we can because we are designers following the code. So that's more like the situation. So we are not more expensive, that's the first thing we need to achieve. And second, and very important, is that when you use local materials in the construction industry, you are involving farmers in the value chain of the construction industry. When you build only using concrete, farmers don't get a peso from the construction industry. But now they get between 20 to 30% of the material costs go to farmers and the people involved in the value chain of bamboo production. So people working on the treatment facility, the guy who drives the truck to move the bamboo here and there. So all of them get revenue. So you leave the money in the locals communities and have nothing against big corporations, but not only to big corporations that produce the cement and the steel and those things. So, and it's still you have carpenters, masons working, so you just involve other sectors that never get benefits from the construction, plus the environmental benefits of having 70% lower carbon emissions. So there's many things that we can gain with this kind of technologies, being more promoted in the country. So that's what BASE and HILT is trying to achieve.
so you have projects on beach, beach resorts. You have projects like that.
That's not. We have a lot of requests because, of course, this one, if you invest a little bit more, you can make it a very nice cabin for vacations in the beach. But that's not for poor people. So we redirect them to consultants that can design. But it's a technology that can be used for the tourism sector as well. I mean, one of the things you go to Bali, for example, and you see all these resorts made in bamboo, and the foreigners paying 300.
So currently you don't cater to that
No, we are
sector,
not.
yeah.
We are social. We are totally social. We are looking for solutions for the poorest of the poor. So let's go outside.
500,000 doon.
283. Yeah.
280
The walls inside should be plastered to avoid the bamboo to be in touch with the humidity.
for the...
Kasi bawal dito sa
But it's the same.
nababasa.
So, to look the house, not at me. Look at the house in this corner. And this is very important. Get a house like the house we got. So that the second part you see the house partially finished, but this is how the house look in the exterior when it's done. So the first thing you see is a concrete house. You already know this is a bamboo house, but if you didn't know that before, and I showed you this picture of this corner, you would think this is a concrete house.
Yes.
Okay? So that has two intentions. One, the concrete in the exterior has a purpose to protect the bamboo inside. With that, we can guarantee the durability of the house. This technology is inspired in Latin American technology, but also exists in the Philippines, as the name here during the Spanish colonial time was tabique pampano, and in Latin America it's called bareque. And in Colombia, in the country, we have houses 200 years old using a similar technology, and the secret is the bamboos are never exposed to the exterior. Bamboos are inside there. And if you keep your bamboos far away from sun radiation, UV radiation, and rain, the bamboos last forever. And it's well treated, you don't have any problem. The second reason we like to use the plaster is because acceptance. You can people, many people that you are going to make a bamboo house, they say, oh, I don't have a house. Because that will be eaten by Bangkok, and I grew up in a Baha'i, I want a modern house, that looks like a concrete house of the okay, that is what they want. And when they say this house, they say, oh no, but this is nice, this looks like my aspirational house. So it helps us also to gain the acceptability of the single one.
This help in the low income or the no income. So solving it, I don't think we are in a position to solve the problem, but we are in a position to help with other solutions or supporting solutions. But there's not just one. Like I said, it's a daunting task. We all have to work together. So that's why we work with Habitat for Humanity. We, together with Habitat, work with local government to see, how we can help. So that's where we're at. It's a matter of what our preference are. Of course, as an organization, we do horizontal development up to 2 stories. But if you were to ask me what's better for high-rise, horizontal, or vertical, there's no one or the other answer. It needs to go together, depending on what's appropriate for the location or what's appropriate for the community. If you were talking about city, Metro Manila, even metro cities, where land is a problem, then definitely you go vertical, because that's how you can address housing needs. But if we were talking about the provincial rural areas, and your future homeowners, let's say, are fisher folk, farmers, even in the informal settlement areas of rural, then you would go horizontal. I don't foresee a farmer or a fisherman right now appreciating being given a 10th unit on the 10th floor. I mean, how is he going to see where his bangka is, or how is he going to put all his, if you were a farmer, whatever you're carrying to the field, where would you put it if you were on the 10th floor? So again, it's about what is appropriate. What is appropriate based on the needs and wants of your homeowner, of your future homeowner or your target beneficiary. Plus, what land is available. Of financing is always our problem. So let's also see where are the funds going to come from and how are the people going to pay for it if they can. Hanggang ano ba yung kaya ng tao? In disaster-prone areas or those that are victims of disaster, many of them will not have anything to pay you. They've just lost everything else. So these are where we come in on maybe grant models, but then there are some that have a savings program. So some of the CSOs continue to have savings programs. In the past, like Ariane mentioned, they can do up to 500, 1,000 contributions, so subsidy. So again, high-rise, horizontal, I think we need everything we can get at this point with the 6.8 million housing gap.
Horizontal, most of our construction is horizontal, especially pag nasa rural areas tayo. But we're supporting the government's program. We're in discussion with them to see how we could also support yung vertical. Hindi lamang kami close na horizontal lahat, no? Sabi nga ni Marisa, parang let's do both, horizontal, vertical, depending on the need and the availability of land. Kasi we also have to listen to the people that we work with. Kasi kung ayaw nila ng horizontal, ng vertical, even if we build vertical, later on, magiging empty rin yung the buildings that we are, or the house that we will be constructing. So, there should also be a discussion with the community and then with the LGUs. And of course, we really need the support of the government in the things that we do. In our project in Negros Occidental, parang nakaano nga yun parang hold, because we want kasi yung source of funding for the project ay sustainable also. So that's why we need work with the LGUs, we need to partner with developers, private sector, para yung mga house na binibuild namin, mag-continue siya and the families will be able to live in those houses.
Kaya sa what they can pay, but kaya in terms of future maintenance. So this is why we design na at low maintenance as possible. For probably vertical developments, there are many more things to consider. Because you have common areas, you have elevator systems that you need to pay for, you have, if the 10th floor leaks down to the 9th floor, sino magpapaayos? So those are considerations that I think we all also need to take a look at when we're building high-rise, and whether the community has the capability as a homeowners association to address all those needs. The same way in vertical, who maintains roads, road networks, yung common areas, community centers. So that's the reason why Habitat also takes a look at community development, social preparedness, how do people learn to live together. So these are many, I think, considerations whether we go vertical, horizontal, really depending. Again, importante yung understanding the needs and the wants of the people who are going to benefit from what we do. Training programs ongoing. So we have CPD training programs. This trains architects and engineers, and then they get credits for CPD points. Then there are programs that we have for contractors. Contractors who are building together with us, like let's say it's Negros, they're contractors that build with us, then we train those contractors to learn how to build with this system. In this year alone, we've been getting a lot of requests from different contractors or different private groups that want to build with the technology for commercial purposes. So what we are doing now is taking a look at how we can also address that, because the more people use the technology, the better for the environment, right? So we'd want to encourage people to use it. So now what we're trying to see is, as a foundation, because we are non-profit, how will we go about with addressing requirements of, you said you were a contractor, diba? But you'd want to use it for commercial purposes, for your glamping sites and all. So we're seeing how we can either take it in a form of a donation or fees, depending on what the legal structure can take as a foundation without making any profit, but whatever we generate will in turn be used to build more houses for those who cannot afford. So we're getting there, and we will let you know. But right now, while we don't have our final structure for such donations or charge or whatever, all the training that we give for architects and engineers on CPD are given for free. So those are for free for now. We'd like to encourage actually contractors to build because same as you said, sometimes we get requests for 5 houses. We cannot deploy just for 5 houses because it's not, we are a small team. Base is less than 25 people, all in all. And we are all over the different projects. So what we do is we deploy engineers to take a look at how construction is, then can move on to a next project and then come back if there's any concern or at specific points in the construction to check what's correct and what's not correct. Design, that's of course all under Luis. Design, structural analysis and all comes from that as well.
So for other inquiries, it's www.base-builds.com.
Yes, or at basebuilds.com or at info@base.bahay.com.
So for those contractors who would want to undergo training, how can they reach you? Those social media pages and
You
my
can just
email.
email info@base-bahay.com.
Are there any requirements?
Architects license.
Licensed architects and engineers can watch out on our social media
And CPD.
for CPD courses. When's our next one? Where's
I don't think we have this here. Maybe
For
online.
schedules,
we just finished kasi one face to face but maybe we will have an online one before the year ends, and you will find all the schedules in the
For
social.
other videos where they can check it out. I mean, you have YouTube
In our
accounts.
social media,
Social
you can
media
find
accounts,
a
yes.
lot of information.